Welcome to Cosmos in a Pod Space and Astronomy series, Episode 8.
Episode 8, that's right.
Today,
Yeah.
we're taking a deep dive into our solar system.
Okay.
We're going beyond those basic facts you find in textbooks,
Right.
to really uncover what makes each planet unique and special.
That's what we're here for, those hidden wonders,
Yeah.
those surprising things that we don't always hear about.
Right. And so to kick things off, let's start right at the heart of it all, the sun.
The big one.
The big one. It's easy to forget, I think, that it's not just, lighting our days,
Yeah.
but it really dictates the rhythm of our entire solar system.
It really does. I mean, it holds 99.8% of the entire solar system's mass.
Wow.
So it's the dominant force in shaping everything, the orbits, destinies of everything.
Just like our cosmic anchor,
Exactly.
holding everything together.
Exactly. And that immense power, it all comes from the sun's core, where nuclear fusion is happening constantly.
Okay.
So hydrogen atoms are being squeezed together under immense pressure.
Fuse into helium, and they release this tremendous amount of energy.
So it's like this giant nuclear reactor powering the whole solar system.
It is a giant nuclear reactor, a good analogy.
Oh, wow.
And it's not a constant, steady process either. The sun actually goes through cycles of activity.
Right.
So you have periods of intense solar flares, coronal mass ejections.
And those can actually cause some disruptions here on Earth, right?
Absolutely. These solar storms,
Yeah.
they can interfere with communications, they can disrupt power grids, even pose risks to satellites and astronauts.
Right. So it's a delicate balance then between that dependence and caution.
It is.
All right. So why don't we hop over to the innermost planet, Mercury,
Okay.
which often gets overlooked, I think,
Yes.
but it's fascinating in its own right.
It is. It's the smallest planet, but it experiences some of the most wild temperature swings in the solar system.
Really?
Imagine going from 427 degrees Celsius during the day
Wow.
to negative 173 at night.
Oh my goodness, that is an extreme swing.
Yeah. That's like going from an oven to a freezer in a matter of hours.
Yeah.
But what I find really interesting is that there's evidence of water ice on Mercury.
Yeah.
How is that even possible?
Yeah, it's definitely a bit of a head scratcher when you think about those extreme temperatures.
Right.
The ice is found in permanently shadowed craters at Mercury's poles, you see.
Okay.
These areas never see sunlight.
Right.
So the temperatures remain low enough for that ice to just stay there.
Oh, wow. So it's like a scorching desert with these secret pockets of ice.
Exactly.
What other surprises does Mercury hold?
Well, one of the biggest mysteries is its disproportionately large core,
Okay.
which accounts for about 85% of the planet's volume.
Wow.
That's much higher than any other planet we know of.
Really?
And this massive core generates a surprisingly weak magnetic field, which is unexpected given its small size.
Interesting. So a small planet with a big heart, both literally and figuratively.
Yeah.
Okay. Next stop on our planetary tour,
Okay.
Venus. This one has a reputation as Earth's evil twin.
Right. And I think that's pretty accurate. Venus is similar in size and composition to the Earth, but its environment is very different.
Well, I've heard it's pretty hellish.
Yeah, that might be an understatement. Venus has surface temperatures hot enough to melt lead,
Wow.
exceeding 470 degrees Celsius.
That's incredible.
And this is due to something called a runaway greenhouse effect,
Okay.
caused by its incredibly thick carbon dioxide atmosphere.
So while Earth has this balanced greenhouse effect, right?
Right.
That keeps our planet habitable, Venus kind of took it to the extreme.
Exactly. The dense CO2 traps heat like a blanket,
Yeah.
creates this scorching inferno underneath a thick blanket of sulfuric acid clouds.
Wow. That sounds pretty inhospitable.
It's a hostile environment that has made exploration a big challenge, yeah.
So no wonder we haven't sent any astronauts there. But what does it look like beneath those clouds?
It's a world shaped by volcanic activity.
Okay.
Imagine vast plains, towering volcanoes, and these strange pancake-like domes.
Pancake-like domes.
Yeah, formed by thick lava flows. It's a world that's both beautiful and terrifying.
It really does sound like a scene out of a sci-fi movie.
It does.
And get this, Venus also rotates backward compared to most planets in our solar system.
It does, yeah, a retrograde rotation.
Yeah.
Spinning in the opposite direction.
Why is that?
It's one of the many mysteries that scientists are still trying to figure out.
Okay. So we've got a scorching hot, backward spinning planet with a toxic atmosphere.
Yeah.
Definitely living up to its evil twin reputation.
For sure.
So now, let's come back home to Earth.
Our oasis.
Our pale blue dot.
Yeah.
Our oasis teeming with life. What makes Earth so special?
I think what sets Earth apart is this delicate balance of its systems.
Right, so we've got the shifting tectonic plates creating mountains and continents.
Yeah.
We have vast oceans regulating our climate.
Right.
And this protective magnetic field that shields us from harmful radiation.
Exactly.
It really is like the perfect recipe for life as we know it.
It is.
And it's not just on the surface either. I was reading that there are thriving ecosystems in the deep ocean around hydrothermal vents.
Right.
But it's in complete darkness.
It is.
How is that possible?
These vents release heat and chemicals from the Earth's interior, and that provides energy for these organisms that have evolved to survive in those crazy environments.
That's wild.
It is.
So life really can exist in the most unexpected places.
It can.
And it really highlights how crucial those Earth processes are, like recycling carbon and water, to keep this whole habitable environment going, something we often take for granted.
Yes, we do take it for granted.
But it's essential for life as we know it.
Absolutely.
Okay, so speaking of habitability,
Yes.
let's shift our focus to a planet that has captivated our imagination for centuries.
Okay.
Mars,
Mm.
the red planet.
The one everyone's looking at.
Yeah, it holds clues to the past and maybe possibilities for the future.
Yeah, it really does.
What secrets has it been hiding?
Mars today is a cold, arid planet with a thin atmosphere.
Right.
But there's evidence it wasn't always this way.
Right.
We see ancient riverbeds, deltas, lake beds, all suggest that liquid water once flowed on the surface.
So we're talking about the possibility of ancient life then.
It's a real possibility. The presence of liquid water in the past makes it a prime candidate for having harbored life. And even today, there's evidence of vast reserves of frozen water beneath the surface.
Wow.
And perhaps even liquid water in underground lakes.
That's fascinating. No wonder we have rovers like Perseverance out there exploring,
Exactly.
searching for signs of past or present life.
It's a time capsule holding clues
Yeah,
to the history of our solar system, maybe even the origins of life itself.
this has already been an incredible journey, and we've only just begun.
I know, right?
Next, we'll venture out to the gas giants,
Oh, yeah.
where swirling storms, icy rings, and fascinating moons await.
Get ready. Buckle up.
Yeah, it's going to be quite the cosmic adventure.
It will. And now we're venturing into the realm of gas giants, a region of our solar system where size and scale
Yeah,
take on a whole new meaning.
they do.
And what better place to start than with Jupiter, the king of planets?
It's hard to even comprehend just how big Jupiter is compared to Earth.
It's true.
Yeah.
Its diameter is over 11 times that of Earth, and you could fit more than 1,300 Earths inside it.
That's insane.
Yeah, but it's not just the size, it's a world of dynamic weather, incredible features.
Okay, well, speaking of features, we can't talk about Jupiter without mentioning the Great Red Spot.
Of course.
This storm has been raging for centuries, and it's bigger than our entire planet.
It's an iconic feature, a swirling vortex of red-hued clouds with winds exceeding hundreds of kilometers per hour.
Wow.
It's been observed for at least 4 centuries, but what's interesting is that it's slowly shrinking.
Shrinking?
Yeah.
You mean this massive storm could eventually disappear?
It's a possibility. Scientists are still studying why it's shrinking and what the fate of the Great Red Spot might be. It's a reminder that even in the vastness of space, things are constantly changing.
Yeah, like a cosmic mystery unfolding right before our eyes.
Exactly.
But Jupiter's wonders extend beyond its stormy atmosphere, right?
Right.
What about its moons? Specifically, Europa, which has captured the attention of a lot of scientists searching for life.
Yeah, Europa is an intriguing world. It's covered in a thick shell of ice.
Right.
And beneath that ice, scientists believe there is a vast global ocean of liquid water,
Wow.
possibly twice the volume of all the oceans on Earth combined.
An ocean on a moon.
Yeah.
That's incredible. But how can liquid water exist so far from the sun?
It's thought that tidal forces from Jupiter's gravity, along with the moon's internal heat, create enough energy to keep the water beneath the ice in a liquid state.
So it's like this giant tug of war creating friction to melt the ice.
It's a good way to think about it, and what makes Europa even more exciting is that this ocean could potentially harbor life.
So alien life swimming around in an ocean on Jupiter's moon.
It's a possibility that scientists are very eager to explore further. There are future missions planned to study Europa in more detail, searching for signs of life, analyzing the composition of its ocean.
And if we do find life on Europa, what would it even look like?
Yeah.
Would it be similar to life on Earth or something completely different?
That's the beauty of exploration. It pushes the boundaries of our understanding and opens up new possibilities.
Absolutely.
And Jupiter itself has a formidable boundary, its
Yeah.
magnetic field.
Well, I've heard it's the most intense magnetic field in our solar system.
It is. It's so powerful that it traps charged particles from the solar wind, creating these amazing auroras at its poles, just like the northern lights that we see on Earth.
Jupiter has its own version of the northern lights.
It does.
That's spectacular.
It's a light show on a cosmic scale.
Hmm.
Now let's move on to another ringed beauty, Saturn.
Okay.
It's a planet that captivates us with its elegance and grandeur.
Well, Saturn's rings are truly iconic. They're like a celestial ballet.
They are.
This delicate dance of ice and dust.
And what's remarkable is that those rings are surprisingly young. Astronomically speaking, they may have formed only about 100 million years ago,
Oh, wow.
which is relatively recent in the grand scheme of our solar system's history.
Yeah. I would have thought that they were as old as the planet itself.
Right.
But if they're that young, how did they even form?
There are a few theories. One possibility is that a moon or a comet got too close to Saturn and was torn apart by its gravity.
Oh, wow.
Another theory is that the rings formed from material left over from the formation of Saturn itself.
Interesting. Either way, it's a reminder that our solar system is a dynamic place, things constantly evolving and changing.
It is.
But Saturn's allure extends beyond its rings, what lies beneath its swirling clouds.
Deep down, Saturn is a gas giant, core of rock and ice, similar to Jupiter. But what sets Saturn apart is its density. It's actually the least dense planet in our solar system, less dense than water. So if you had a bathtub big enough, Saturn would float.
A floating planet.
A floating planet.
That's an image. But Saturn has more to offer than just its density.
Oh, yeah.
It also boasts a fascinating collection of moons.
It does. Saturn has over 80 moons.
Wow.
Each with its own unique story to tell. And one moon in particular has captured the attention of scientists looking for life beyond Earth, Enceladus.
Enceladus, the icy moon with geysers erupting from its south pole.
Yes.
I remember seeing images of those geysers spewing water vapor and organic molecules into space.
Right. Those geysers are a sign that there's a vast ocean beneath that icy shell. And the presence of organic molecules, the building blocks of life, makes this moon a prime candidate for hosting extraterrestrial life.
Another ocean moon.
Another ocean moon.
It seems like they're more common than we once thought.
They do, yeah.
What makes Enceladus stand out is that we've actually sampled those geysers.
Right. The Cassini spacecraft, it flew through those plumes and collected data revealing the presence of organic molecules, salts, and even tiny grains of silica.
So not only do we have evidence of this vast ocean, but also possible hydrothermal vents,
Yes.
similar to the ones found on Earth,
Right.
that support life in the deep ocean.
Exactly. Enceladus has become one of the most promising places to search for life beyond Earth. And it's a testament to the power of exploration, how each new discovery opens up new possibilities and challenges our understanding of the universe.
This journey through the gas giants is already mind-blowing. From shrinking storms to floating planets to ocean moons,
I know, right?
the scale and diversity of these worlds is just incredible.
And we're not done yet.
Oh, there's more.
Next, we'll delve into the ice giants.
Okay.
Uranus and Neptune, worlds that lie in the distant reaches of our solar system, shrouded in mystery and wonder. And as we venture even further into the outer solar system, we encounter the ice giants,
Okay.
Uranus and Neptune.
All right. The ice giants. These are definitely the less famous siblings of the gas giant family.
Right.
What makes them so different from Jupiter and Saturn?
Well, as their name suggests, ice giants are composed mostly of ices,
Ices.
but not just water ice.
Okay.
We're talking about ices of methane, ammonia, other compounds swirling around this rocky core.
Right.
This composition gives them their distinct bluish hues.
So they're like giant slushies with a rocky center.
That's one way to put it.
Yeah.
And these icy giants, they have some pretty quirky characteristics. Let's
Yeah.
start with Uranus, the planet that just seems to be doing its own thing.
Okay.
Yeah.
Well, I've heard that it's tilted on its side.
It is.
Is that true?
Yeah. Uranus has an axial tilt of 98 degrees, meaning it's practically rotating on its side as it orbits the sun.
What? So imagine a planet rolling around like a ball instead of spinning like a top?
Exactly.
That's crazy. What causes such an extreme tilt?
Scientists believe that early in the solar system's history, a massive object collided with Uranus,
Oh, wow.
knocking it off its axis.
Wow. And this tilt creates some really unusual seasons on Uranus, with each pole experiencing decades of sunlight followed by decades of darkness.
Wow, talk about extreme weather. And I remember hearing that Uranus has rings, too.
It does.
Not as prominent as Saturn's.
Yeah, Uranus has a system of faint rings discovered in 1977. They're much darker, less massive than Saturn's rings, and they're thought to be composed of dust and rock rather than ice.
So it's like a cosmic echo of Saturn's grandeur,
Yeah.
but with this kind of darker, more subdued beauty. And what about its moons?
Oh, Uranus has at least 27 moons,
Wow.
and some of them show signs of geological activity, which is surprising considering how far away they are from the sun.
Right.
For example, Miranda, one of Uranus's moons, it has a surface that looks like a giant jigsaw puzzle,
Really?
with canyons and cliffs and these strange grooved terrains.
Wow, it sounds like a moon that's been through some rough times.
Definitely suggests a dynamic history.
Okay.
Now let's move on to Neptune.
The outermost planet in our solar system. A world shrouded in mystery and powerful winds.
Neptune is known for its deep blue color,
Yes.
which I'm imagining comes from all that methane ice in its atmosphere.
You're right. The methane absorbs red light and reflects blue light,
Okay.
giving Neptune that striking azure hue. And it's not just beautiful, it's a planet of extremes. Neptune boasts the fastest winds in the solar system,
Right.
reaching speeds of over 2,100 kilometers per hour.
That's over 1,300 miles per hour.
Oh.
Anything caught in those winds would be shredded to bits.
Oh, yeah.
What drives such intense winds on a planet so far from the sun?
Scientists believe that the internal heat of Neptune, combined with its fast rotation, creates the conditions for those powerful winds. And it's not just the winds that are extreme. Neptune also has a surprisingly dynamic atmosphere
Okay.
with storms that come and go.
So even though it's so far from the sun, it's a world that's full of energy and activity.
Yes, very active. What about its moons?
Okay, yeah. Does Neptune have any notable companions?
It does. Neptune has 14 known moons, and the most interesting one is Triton.
Triton.
Yeah, a moon that stands out for a couple of reasons. First, it's the only large moon in our solar system that orbits its planet in the opposite direction of the planet's rotation.
Really?
This suggests that Triton was likely captured by Neptune's gravity.
So a captured moon,
Yeah, rather than forming alongside it.
like an interloper from another part of the solar system.
That's the leading theory.
Hmm.
Triton is also notable for its icy volcanism.
Wow.
Instead of spewing molten rock, these volcanoes erupt with nitrogen gas and ice particles,
Ice volcanoes.
creating this strange and beautiful landscape.
That sounds like something straight out of a science fiction novel.
It does, doesn't it?
It's amazing to think about the diversity of worlds in our own solar system.
It is. From scorching hot surfaces to icy geysers and extreme winds.
Yeah.
Our solar system is a tapestry of wonder and diversity, and we've only just begun to explore its secrets.
Well, speaking of exploring, we can't forget about the dwarf planets, especially Pluto, which holds a special place in our hearts,
Pluto, yes.
even though it's no longer considered a full-fledged planet.
Right. Pluto may have been reclassified, but it's still a fascinating world.
It is.
And the New Horizons mission gave us our first close-up look at this distant dwarf planet in 2015,
Right.
revealing a surprisingly complex and diverse surface.
I remember seeing those images of Pluto's heart-shaped nitrogen glacier,
Yes.
its towering mountains of water ice,
Yes.
and its vast plains of frozen nitrogen.
And there's evidence that Pluto might even have a subsurface ocean,
Oh, wow. Another ocean world.
hidden beneath its icy shell.
It seems like they're everywhere we look.
They do seem to be. But Pluto isn't alone out there, right?
Right.
What lies beyond Pluto?
Yeah, what is out there?
Beyond Neptune, we enter the realm of the Kuiper Belt, a vast region filled with icy bodies, dwarf planets.
Right.
It's like a cosmic graveyard, holding remnants from the early formation of our solar system.
So it's like a time capsule, offering clues to the processes that shaped our solar system billions of years ago.
Exactly.
Wow.
Studying these objects can help us understand the evolution of planetary systems.
Right.
Not just our own, but those around other stars.
So it's a reminder that our solar system is just one small part of a vast and intricate universe.
It is.
And we're constantly learning more about our place in this cosmic expanse.
We are. And that journey of discovery, it's far from over.
Absolutely.
There are countless mysteries still waiting to be unraveled, countless stories waiting to be told.
So keep looking up, folks, because the next great discovery could be just around the cosmic corner.
And don't forget to follow and subscribe to Cosmos in a Pod for more deep dives into the mysteries of the universe. We'll see you next time, space explorers.